Anticipated 50% investment surge in space exploration, astrobiology, and renewable energy sectors by Q2 2028. Executive Summary. A confluence of advancements and strategic priorities is projected to drive a remarkable 50% surge in investments in the domains of space exploration, astrobiology, and renewable energy by Q2 2028. This report synthesizes findings from key industry analyses and projections outlining the factors contributing to this anticipated growth and the implications for global leadership and sustainability. 1. Overview of investment trends. 1.1 Space Exploration and Astrobiology. The space exploration sector is witnessing unprecedented investment levels, particularly from private entities. By Q3 2024, U.S. space technology startups raised a record $3.5 billion, signaling robust investor confidence in areas such as satellite communications, propulsion technologies, and space debris management. NASA's budget is projected to increase to approximately $26 billion in 2025, primarily aimed at advancing missions like Artemis, which aspires to return humans to the Moon, and various Earth observation projects focused on climate change. Despite these optimistic trends, NASA's astrobiology program faces potential funding cuts which could jeopardize critical missions such as Mars Sample Return and the Europa Clipper mission. A white paper from astrobiology leaders has stressed the urgency of maintaining funding and workforce support to preserve U.S. leadership in astrobiological research, which holds significant socio-scientific implications. 1.2 Renewable energy. The renewable energy sector is poised for a transformative shift, with a report from S&P Global forecasting that investments in clean energy will exceed those in oil and gas by 2025, reaching a staggering $670 billion. Solar energy is expected to dominate this growth, representing half of all clean energy investments. Battery energy storage systems (BESS) are also projected to see substantial growth, essential for stabilizing grids in regions with high renewable penetration. The push for renewable energy is underpinned by a global commitment to combat climate change alongside rapid technological advancements. However, challenges remain, including the impact of Chinese manufacturing on global pricing and trade tensions that may affect U.S. solar policies. 2. Key themes and convergences. 2.1 Investment growth. Both sectors, space exploration and renewable energy, are experiencing significant investment increases driven by technological innovations and strategic government priorities. The anticipated 50% surge by Q2 2028 reflects a growing recognition of the importance of these sectors in addressing global challenges. 2.2 Government support. Government initiatives are crucial in both arenas. NASA's planned budget increases and the global transition towards renewable energy are indicative of a broader governmental commitment to tackling climate change and enhancing space exploration capabilities. 2.3 Public enthusiasm. Public interest in space exploration and astrobiology is robust, creating a favorable environment for securing funding and support. The excitement surrounding potential discoveries in astrobiology, especially in the search for extraterrestrial life, resonates with a wide audience, further driving investment. 3. Comparative analysis of sources. Source 1 emphasizes immediate growth trends in the space sector, highlighting employment opportunities and company consolidation. Source 2 focuses on the risks to NASA's astrobiology program amid potential funding cuts, calling for increased support to maintain momentum in this critical field. Source 3 centers on renewable energy, detailing financial projections and innovations without a direct connection to astrobiology. 4. Timeline of projected developments. Early 2025, continued private investment in space technology is expected, along with NASA's budget increase to $26 billion. 2025, clean energy investments are predicted to surpass those in oil and gas, with solar energy leading the charge. Q2 2028, the anticipated investment surge of 50% across the sectors is expected to be realized, driven by ongoing advancements and public support. 5. Sector-specific insights. 5.1 Space sector developments. Private investment. The burgeoning interest in space technology is reflected in significant funding for startups exploring innovative solutions in satellite communications and space debris management. Employment trends. The U.S. space sector witnessed a 4.8% growth in employment in 2024, with projections suggesting further increases in 2025 driven by expansions in satellite manufacturing and space tourism. 5.2 Renewable energy innovations. Solar dominance. Solar energy is expected to account for a substantial portion of clean energy investments, with projections indicating over 620 gigawatts of new solar and wind capacity by 2024. Battery storage growth. The demand for battery energy storage systems is on the rise, essential for integrating renewables into the grid and ensuring energy stability. 6. Challenges ahead. Despite the optimistic outlook, both sectors face challenges. Space sector risks. Potential funding cuts to NASA's astrobiology program could hinder critical missions and delay significant discoveries. Renewable energy hurdles. Trade tensions and manufacturing dynamics, particularly influenced by China, pose challenges for the U.S. solar market and overall clean energy transition. 7. Conclusion. The confluence of increased funding, technological innovation, and public enthusiasm in space exploration, astrobiology, and renewable energy signifies a pivotal moment for these fields. By Q2 2028, the anticipated 50% surge in investments is expected to reshape global leadership and sustainability efforts, providing a solid foundation for addressing the pressing challenges of the 21st century. 8. Recommendations. To capitalize on these opportunities, stakeholders in both sectors should advocate for robust funding, support initiatives to secure sustained funding for NASA's astrobiology program and other critical research areas, enhance public engagement, foster public interest through educational campaigns and outreach programs that highlight the importance of space exploration and renewable energy. Promote collaboration, encourage partnerships across government, industry, and academia to drive innovation and address the challenges facing both sectors. In summary, the significant investment surge anticipated by 2028 presents a unique opportunity to advance our understanding of the universe and transition towards a sustainable energy future. The anticipated 50% investment surge in the sectors of space exploration, astrobiology, and renewable energy by Q2 2028 reveals several counterintuitive insights that challenge conventional expectations about these fields. 1. Space exploration and astrobiology funding cuts. While the overall investment in space exploration is increasing, there is a paradoxical risk of funding cuts in the astrobiology sector. As noted, NASA's astrobiology program is facing potential funding reductions despite its critical role in major upcoming missions like Mars Sample Return and Europa Clipper. This situation is counterintuitive because one might expect that as interest and investment in space exploration grow, funding for essential research areas like astrobiology would also naturally expand. However, the reality is that budgetary constraints and prioritization of certain missions over others may lead to a scenario where vital research areas are jeopardized, potentially hindering future discoveries about life beyond Earth. 2. Renewable energy outpacing fossil fuels. The report indicating that clean energy investments will surpass those in oil and gas by 2025 might seem expected given the global emphasis on sustainability. However, the speed at which this transition is occurring is counterintuitive. It suggests a rapid re-evaluation of economic priorities, with significant investments in solar energy, battery storage, and AI technologies for grid management expanding faster than anticipated. This shift might challenge the long-held belief that fossil fuels would remain dominant for longer due to entrenched economic interests and infrastructure. 3. Public passion versus funding reality. The strong public passion for space exploration and astrobiology is driving funding and support, yet this enthusiasm does not always translate into financial backing where it is most needed. For example, despite widespread public interest in the search for extraterrestrial life, the astrobiology program faces funding challenges that could undermine its viability. This discrepancy highlights a counterintuitive dynamic where public support exists but actual investment flows do not align with that enthusiasm, potentially stalling progress in a field that captures the imagination of many. 4. Technological advancements versus economic pressures. The expected growth in sectors like space technology and renewable energy is occurring amidst economic pressures, such as rising interest rates and inflation. This creates a counterintuitive situation where, despite challenges in the broader economy, significant investments are still being funneled into high-risk sectors like space exploration and renewable energy. One might expect that economic uncertainty would lead to a reduction in exploratory investments. However, the opposite seems to be true, suggesting a robust confidence in the long-term viability and necessity of these sectors. 5. Chinese manufacturing influence. The anticipated growth in renewable energy investments, particularly in solar power, is also challenged by the dominance of Chinese manufacturing. While the US and other countries are ramping up their clean energy technologies, the ongoing influence of China in pricing and manufacturing dynamics presents a counterintuitive barrier to achieving the desired growth. Despite efforts to bolster domestic production through policies like the Inflation Reduction Act, the reliance on Chinese components could complicate the transition and affect investment stability. 6. Job growth in space sector amid consolidation. The space sector's employment growth is projected to continue despite a trend towards consolidation, which typically leads to fewer larger companies dominating the market. This is counterintuitive, as one might expect that consolidation would lead to job losses. Instead, as larger firms acquire smaller startups, the overall demand for skilled labor in the space industry is increasing. This reflects a broader trend where the integration and scaling of operations may create new job opportunities even as the number of independent entities decreases. 7. The role of AI in renewable energy. The integration of artificial intelligence (AI) into renewable energy management is set to revolutionize the sector, providing unexpected efficiencies and innovations. This trend might seem straightforward, however. The rapid application of AI in forecasting energy generation and optimizing grid integration is outpacing traditional methods more quickly than anticipated. This suggests a counterintuitive acceleration where technology not only supports but drives the growth of an entire sector, fundamentally altering its operational landscape. 8. Investment prioritization in an uncertain climate. The significant investments in renewable energy come despite ongoing trade tensions and regulatory uncertainties, particularly in the solar sector. It is counterintuitive that investors would commit to such large-scale projects amid potential regulatory shifts and international trade disputes. This indicates a strong belief in the long-term benefits of renewable technologies, showcasing a willingness to take on risks that may not align with traditional investment strategies that favor stability over innovation. Conclusion. The anticipated 50% investment surge in space exploration, astrobiology, and renewable energy sectors by Q2 2028 reveals numerous counterintuitive dynamics. From the paradox of funding cuts in the face of rising public interest to the rapid growth of clean energy despite economic pressures, these insights challenge conventional wisdom and underscore a transformative moment in these interconnected fields. The ability to navigate these complexities will be crucial for stakeholders aiming to leverage the opportunities presented by these significant investment trends. The report on the anticipated 50% investment surge in space exploration, astrobiology, and renewable energy sectors by Q2 2028 contains significant details that many might overlook yet are crucial for understanding the broader implications of these developments. Here are the key points that deserve deeper attention. 1. Astrobiology funding cuts. One of the most critical aspects of the report is the potential funding cuts to NASA's astrobiology program. While much focus is given to the exciting missions like Mars Sample Return and Europa Clipper, the underlying threat to astrobiology funding is significant. This could undermine the U.S. leadership in this pioneering field, crucial for answering fundamental questions about life beyond Earth. The astrobiology community's push for robust support is a plea not just for funding but for maintaining a scientific legacy that has profound implications for humanity's understanding of its place in the universe. This aspect is often overshadowed by the more glamorous aspects of space exploration but is vital for maintaining momentum in groundbreaking research. 2. Technological innovations in renewable energy. The surge in renewable energy investments, particularly in solar and battery technologies, reflects a broader trend that might be easily overlooked amid discussions of dollar amounts. The projected growth in battery energy storage systems, BESS, and innovations such as ammonia for low-carbon hydrogen production are game-changers for energy infrastructure. As solar energy is expected to dominate, the implications for energy management, grid stability, and overall sustainability are profound. These technological advancements not only support the energy transition but also create new job opportunities and drive economic growth. The interplay of these technologies with AI for grid planning and forecasting is a significant trend that signals a shift in energy management practices. 3. Global competition in space and energy. The report highlights the ongoing competition with China in both space exploration and renewable energy sectors, as NASA seeks to maintain its leadership. The rise of China's space capabilities and its influence on global energy markets present challenges that could reshape international dynamics. The emphasis on U.S. innovation and the need for strategic investments to counter this competition is essential. This geopolitical aspect is often overlooked but can determine the future landscape of global technology leadership. 4. Public interest and societal impact. The public's passion for space exploration and astrobiology is highlighted, but its significance goes beyond mere enthusiasm. This public interest drives funding, engagement in STEM fields, and the overall narrative around space and science. The societal impact of astrobiological research, including technological advancements that benefit life on Earth, is a compelling reason why this field should not face budget cuts. The potential for inspiring the next generation of scientists and engineers is a critical point that often gets lost in technical discussions. 5. Interconnectedness of the sectors. The report implies a convergence between the sectors of space exploration, astrobiology, and renewable energy that is not explicitly stated but is significant. For instance, advancements in satellite technology and Earth observation can enhance our understanding of climate change and inform renewable energy strategies. This interconnectedness suggests that investments in one area can have far-reaching impacts across the others, which is a strategic insight that stakeholders should consider when allocating resources. 6. Market dynamics and trade tensions. The mention of trade tensions, especially regarding solar technology, is significant. The potential for U.S. tariffs on solar imports could reshape the global market for solar technology, influencing prices and availability. India's emerging role as a key player in the solar market, due in part to these tensions, indicates a shift in manufacturing dynamics that could have long-term implications for energy independence and technological competitiveness. 7. Job creation and economic growth. While investment figures are impressive, the implications for job creation in both sectors are equally important. The report notes anticipated job growth in the space sector and renewable energy, yet the broader economic impact, including potential shifts in workforce skills and regional economic development, deserves more attention. The transition to renewable energy, for instance, will require a workforce skilled in new technologies, highlighting the need for education and training programs. Conclusion. These overlooked aspects of the report underscore the complexity and interrelated nature of the anticipated investment surge in space exploration, astrobiology, and renewable energy sectors. Recognizing the significance of funding for astrobiology, the technological innovations driving renewable energy, the competitive landscape with China, and the broader societal impacts can enhance understanding and inform strategic decisions as we approach a pivotal moment in these fields by 2028. The intertwined nature of these sectors suggests that investments made today will not only shape the future of exploration and energy but also redefine humanity's relationship with science and technology in the coming decades. The anticipated 50% investment surge in space exploration, astrobiology, and renewable energy sectors by Q2 2028 presents several critical points for in-depth analysis and discussion. Here are 4 of the most valuable points. 1. Investment growth and economic implications. The projected surge in investment across these sectors indicates not only a financial commitment but also a transformative shift in priorities at both governmental and private levels. Space exploration and astrobiology. The increase in investment in space technology startups, which have raised a record $3.5 billion by Q3 2024. Reflects a burgeoning private sector interest that complements NASA's projected budget increase to $26 billion in 2025. This influx of capital is expected to bolster employment in the space sector, which grew by 4.8% in 2024 and is projected to continue growing. The implications of such investment are profound, as they can lead to technological advancements, job creation, and the establishment of the U.S. as a leader in space exploration amidst rising competition from countries like China. Renewable energy. The clean energy sector is set to outpace oil and gas investments for the first time by 2025, with projections of $670 billion in spending. This shift underscores a critical economic transition towards sustainable practices. The dominance of solar energy, expected to account for half of the clean energy investments, highlights its role as a cornerstone for future energy solutions. The economic implications extend beyond immediate financial returns. Promoting long-term environmental sustainability and energy security. 2. Government support and policy frameworks. Governmental backing is pivotal in shaping the trajectories of these sectors. In the realm of space exploration, NASA's initiatives like the Artemis program aimed at returning humans to the Moon exemplify a strategic commitment to expanding human presence in space. The proposed budget increase reflects a recognition of the importance of space exploration in addressing global challenges, from climate change to potential extraterrestrial life. For renewable energy, policies such as the Inflation Reduction Act in the U.S. provide essential incentives for clean energy investments. These frameworks are necessary to counterbalance challenges posed by international market dynamics such as trade tensions and the influence of Chinese manufacturing on pricing. The role of government in facilitating a stable investment environment cannot be overstated, as it directly influences the pace and effectiveness of the transition to renewable energy sources. 3. Public interest and societal impact. Public enthusiasm for both space exploration and renewable energy plays a crucial role in driving funding and support. The fascination with astrobiology and the quest for extraterrestrial life resonates deeply with the public, fostering a sense of collective aspiration and engagement in scientific endeavors. This passion not only supports funding but also encourages STEM education and workforce development, positioning the U.S. as a leader in innovative research fields. The outreach efforts to engage the public in astrobiological research underscore the societal relevance of these scientific pursuits. Similarly, the renewable energy sector benefits from public support driven by growing awareness of climate change and sustainability. This collective consciousness has led to increased demand for clean energy solutions, prompting both private and public investments. As the clean energy landscape evolves, the societal impacts such as job creation in green technologies and improved public health from reduced pollution further reinforce the need for a robust commitment to renewable energy initiatives. 4. Challenges and risks. Despite the optimistic outlook, the sectors face significant challenges that could hinder growth and innovation. In the space sector, the potential funding cuts to NASA's astrobiology program pose a risk to the U.S.'s leadership in this critical field. The call for robust funding and workforce support highlights the precarious nature of scientific funding, which, if not addressed, could stifle progress in understanding life beyond Earth. The implications of such setbacks could reverberate through related fields impacting technological advancements and international collaborations. In renewable energy, the influence of international market dynamics, particularly from China, raises concerns about pricing and competition. The ongoing trade tensions and the U.S.'s anti-dumping investigations into solar cell exports could reshape the landscape of solar photovoltaic manufacturing. Addressing these challenges requires strategic policy responses to ensure that the U.S. can maintain competitive advantages while fostering domestic production capabilities. Conclusion: the convergence of increased funding, governmental support, public enthusiasm, and the recognition of challenges presents a pivotal moment for space exploration, astrobiology, and renewable energy sectors. By addressing these key points, stakeholders can better navigate the complexities of investment growth and its societal implications, ultimately paving the way for sustainable advancements by Q2 2028 and beyond. The successful alignment of these factors will not only reshape the economic landscape but also enhance the U.S.'s position as a leader in these critical fields. 1. The Space Race 1957 to 1975. The space race was a period of intense competition between the United States and the Soviet Union, primarily during the Cold War, centered around achievements in space exploration. It began with the launch of the Soviet satellite Sputnik in 1957 and culminated with the U.S. landing astronauts on the Moon in 1969. This historical case illustrates a significant surge in investment in space technology driven by national pride, technological advancement, and strategic military interests. Both nations invested heavily in space programs, leading to remarkable innovations in rocketry, satellite technologies, and telecommunications. Much like the anticipated investment surge in space exploration today. 2. The Green Revolution 1940s to 1960s. The Green Revolution refers to a series of research, development, and technology transfer initiatives that increased agricultural production worldwide, particularly in developing countries. Initiated in the 1940s, it involved the introduction of high-yielding variety HYV seeds, synthetic fertilizers, and advanced irrigation techniques. The significant investments made in agricultural technologies during this period parallel the expected surge in renewable energy investment, is both aimed to tackle critical global issues, food security in the case of the Green Revolution and climate change, and sustainable energy in the case of renewable energy investments. 3. The Manhattan Project 1942 to 1946. The Manhattan Project was a research and development project during World War II that produced the first nuclear weapons. This initiative involved a massive investment of resources, both financial and human, and showcased the power of collaborative scientific research. The project required a significant government commitment and led to unprecedented advancements in physics and engineering. Similar to the anticipated surge in funding for astrobiology and space exploration, the Manhattan Project exemplifies how targeted investments in scientific research can yield transformative results, propelling a nation into a leading position in technological advancements. The anticipated 50% surge in investments in space exploration, astrobiology, and renewable energy sectors by Q2 2028 signifies a transformative shift in how humanity perceives and interacts with both the cosmos and our planet. This growth is driven by a convergence of technological advancements, increased government budgets, and a burgeoning public interest in these fields. Here's a detailed outlook on the future of these sectors. Space exploration and astrobiology. Investment trends. The space sector is poised for unprecedented growth, with private investments expected to continue their rapid ascent. Building on the $3.5 billion raised by U.S. space technology startups by Q3 2024. By 2028, this trend is likely to be amplified by increased funding from both private and public sectors, driven by missions such as NASA's Artemis program focused on lunar exploration and the Mars Sample Return mission. Key areas of growth. 1. Satellite communications. As global demand for connectivity grows, investments in satellite communication technology will soar, particularly in providing broadband internet to underserved regions. 2. Space debris management. With the increasing number of satellites, the need for effective space debris management technologies will drive innovation and investment. 3. Astrobiology research. Despite potential funding cuts, there is a strong push from the scientific community to preserve and enhance NASA's astrobiology program. Essential for missions aimed at exploring Mars and icy moons like Europa. The public's enthusiasm for the search for extraterrestrial life will bolster support for these initiatives. Socio-scientific impact. The exploration of astrobiology will not only advance our understanding of life beyond Earth but will also inspire future generations in STEM fields. Successful missions are expected to yield discoveries that could answer profound questions about our existence, thus enhancing the socio-scientific landscape. Renewable energy. Investment dynamics. The renewable energy sector is projected to surpass $670 billion in investments by 2025, outpacing traditional oil and gas investments for the first time. This transformation is driven by a global commitment to combat climate change and the decreasing costs of renewable technologies. Areas of focus. 1. Solar energy. Expected to account for half of all clean energy investments, solar technology will witness rapid advancements and widespread adoption, with new installations in the gigawatt range becoming commonplace. 2. Battery energy storage systems (BESS). The demand for BESS will surge as renewable energy sources become more prevalent, providing necessary grid stability and facilitating the integration of renewables into existing infrastructure. 3. Innovative hydrogen production. Ammonia is emerging as a viable option for low-carbon hydrogen production, which will play a crucial role in decarbonizing various sectors. Challenges and opportunities. While the future is optimistic, challenges such as global supply chain issues, trade tensions especially with China, and the need for policy frameworks to support domestic manufacturing persist. However, advancements in AI for energy management and the rise of corporate clean energy procurement will further propel the sector towards a sustainable future. Common themes across sectors. 1. Government support. Increased government funding exemplified by NASA's predicted budget rise and various clean energy initiatives will play a crucial role in achieving these ambitious targets. This support is vital for maintaining momentum in research, innovation, and infrastructure development. 2. Public interest and engagement. The growing public passion for both space exploration and renewable energy is a powerful driver of investment. Initiatives that engage the public, such as educational outreach and participatory science, will enhance support for these sectors. 3. Technological advancements. Innovations in technology will be the cornerstone of growth, with advancements in materials science, AI, and engineering enabling breakthroughs in both the exploration of space and the adoption of renewable energy. Timeline of expected developments. 2025, anticipated clean energy investments will exceed those in oil and gas, marking a pivotal shift towards sustainability. NASA's budget increase to approximately $26 billion will facilitate crucial missions. 2026 to 2027, continued advancements in satellite technology and propulsion systems alongside significant discoveries in astrobiology will reshape our understanding of space and life. Q2 2028, the culmination of a 50% investment surge across these sectors will likely lead to a new era of exploration and sustainability, with profound implications for global leadership in technology and environmental stewardship. Conclusion. By Q2 2028, the anticipated investment surge in space exploration, astrobiology, and renewable energy will mark a significant shift in global priorities. This convergence of public interest, government support, and technological innovation is set to reshape our understanding of the universe and our approach to sustainable living on Earth. The next few years will be crucial in determining how these sectors evolve, potentially leading to groundbreaking discoveries and a more sustainable future for humanity.